Welcome to this WiseOwl DAX for Power BI tutorial. In this part of the series, we're going to look at how to compare date ranges in your DAX expressions. So we're going to start with a quick recap of the DateAdd and SamePeriodLastYear functions that we covered in detail in the previous video. Then we're going to look at the previous and next interval functions and how those are related to the ParallelPeriod function. We're going to look at a couple of different ways of writing specific dates in your DAX expressions, and then use those with the DatesBetween function to specify an exact range of dates for your measures. We'll look at how you can calculate the first and last date of an interval, and then at the end of the video, look at how to use the DatesInPeriod function to calculate a moving average. So lots to do in this one, let's get started. To get started, I've created a new blank Power BI report, and as usual, I'm going to import some data about movies from an Excel workbook. Just before I do that, I'm going to head up to the File menu in Power BI Desktop, choose Options and Settings, followed by Options, and then in the dialog box which appears, I want to make sure I've got a particular property set related to dates and times. So in the current file section in the Data Load page, I'm going to head over here and make sure I've got the Auto Date Time option checked. All the time intelligence functions we're going to use in this video rely on all of our date columns in our data model having a calendar table or a date table set up. So rather than go to the effort of creating our own, we're going to rely on the built-in automatic calendar table that Power BI can create for us. We will have a video on how to create your own calendar tables later in this series, but for now we'll stick with the default automatic one. So making sure that box is checked, we can click OK, and then we can choose to import data from our Excel workbook. As usual, I'll drop a link in the video description so you can download this file yourself. It's a cut down version of the standard movies workbook we tend to use, so it's only got movies from 2005 to 2016. I'm going to double click to open up that file. Then there are two tables or two worksheets in here. One is a blank all measures table, which will just save us a little tiny bit of time in creating a measures table in a moment. And then we've got the data table called movies. So it's got all the data contained within there. As you can see, if we click the load button, all of that will be loaded into the basic data model. Okay, so now that that's done, I'd like to start by creating a basic measure to show the total runtime for our films. So I'm going to right click on the all measures table and choose new measure. And then I'll just quickly zoom in on the formula bar so we can see what's going on. And I'm going to call this first measure sum run time. And I'm going to make it equal to the result of the sum function, referring to the runtime column in the movies table. So there's our basic measure. Having created that one, I can delete the delete me column just to tidy up this table. So let's delete that from the model and click OK to confirm we want to do that. And then I'd like to display the value of that measure in a table next to the year that the films were released in. So in the report, I'm going to insert a basic table visual. From the movies table in the fields list, I'm going to find my release date field. And we can see that if we've got this auto date time feature enabled, that release date column will have a date hierarchy built into it automatically. So I can expand that and then select the year component of that hierarchy. And then I can add the sum of runtime field to the same table. Just to tidy up a little bit, I'm going to hide the filters panel, and then with the table selected, head to the format pane and then choose values and bump up the font size to about 13 just to make things a little easier to read. And there we go, there's our first basic table and measure. In the previous video in this series, we looked at a couple of basic time intelligence functions, which allowed us to manipulate the filter context applied when you display different intervals of time in a visual. So in this table, each row has a filter context, which limits the data contained in that row to only films released in that specific year. Just as a quick reminder of something we did in the previous video, I'd like a new measure that allows us to display next to each year the sum of the runtime for the previous year. We have a couple of ways we can do that. Let's get started by creating a new measure in the all measures table. And then I'll call this one sum runtime previous year, or an abbreviation of that at least. And we're going to use the calculate function to modify the filter context. So the expression that I'm going to calculate, I'm just going to reference the existing measure, sum runtime. We could of course nest the sum function in here again, but as we've already gone to the effort of creating the measure, we might as well use it. And then I can apply a filter using a couple of different time intelligence functions. So one fairly simple function we could use would be SamePeriodLastYear. In order to make this one work, all we have to do is refer to the dates column created in the automatic date table. So I'm going to refer to the release date field and then reference the date property of that field, the date property coming from the date table. I'm then going to close the round brackets and then close an extra set of round brackets for the calculate function. Then I can enter that formula and I can add that new measure to my table, and we can see that the value for the preceding year is displayed next to each year in the table. So the SamePeriodLastYear function is quite a specific one. It always takes the range of dates included in the filter context and shifts it back by exactly 1 year. You'll often want a bit more flexibility than that. Let's show how to create the same end result using a more flexible function. I'm going to head back to the sum runtime previous year measure, and I'm just going to make a copy of this one. Then we can create a new measure, paste in all the code we've just copied, change the name to an inventive name like sum runtime previous year 2, and then we can take away the SamePeriodLastYear function and replace that with a more sort of general purpose time intelligence function called DateAdd. Now the DateAdd function provides 3 parameters, and the first one is again the range of continuous dates in your date table. So I'm going to refer to the release date field and the date property of that. Then the next parameter lets you specify how many intervals you want to move forwards or backwards. So if I want to go back 1 year, I can say -1, but if I want to move forwards in time, I can use positive numbers instead. Then finally, I can specify what interval I want to move, so it's not just about moving in years, I can move in days, months or quarter intervals as well. But as here I'm trying to replicate the same example we've just created with SamePeriodLastYear, let's use the year interval, close a set of round brackets for the DateAdd function, and then create that measure. I can then add that new measure into my table. We can see what the names of them are. And then we can see we get exactly the same result using a slightly different function, providing a bit more flexibility in our date ranges. DAX has a large number of time intelligence functions which behave in very similar ways, and that often means that you can achieve the same end result using lots of different techniques. Just to demonstrate that again, I'm going to introduce a new time intelligence function called Previous:Year. So I'm going to head back to the sum runtime previous year measure, and then we're going to copy that. We're going to create a brand new measure, pasting in the code and giving it an equally inventive name, sum runtime previous year 3, and then we're going to take away the SamePeriodLastYear function and then use the PreviousYear function instead. You'll notice that there's also a previous quarter, month and day function for different intervals of time, and if I wasn't trying to go backwards in time, I was trying to go forwards, there are equivalent functions called next, day, month, quarter and year as well. This one, though, I'm trying to replicate the same example, so I'm going to go for previous year, open some round brackets. There's one compulsory and one optional parameter, so dates, again, being the continuous range of dates in your date table, and an optional year end date. We'll just stick with the same example, so we'll just refer to the release date and then the date property of that to get the same end results. Create that new measure, and then we can add that one into the table. And we can see, once again, the same results as previously. One subtle difference is the lack of a grand total at the bottom, but the important thing is that for each year, we can see the sum of runtime for the previous year. Now, the names of some of the DAX time intelligence functions can be a little misleading. Taking, for example, the PreviousYear function we've just used here. If you see it in an example like this, you'd be forgiven for thinking that the PreviousYear function behaves in an almost identical way to the SamePeriodLastYear function or the DateAdd -1 year. But that's not quite true. We can expose the quite different behaviour of the PreviousYear function by including extra intervals in our visual. I'm just going to change the visual from a table to a matrix, and then I'm going to include the quarter and month intervals in that matrix. So at the moment we're still seeing the same results. Let me just change the size of this visual again. What I'm going to do now is I'm going to drill down so that we can see not just the year levels but also the quarter levels. So I'm going to click this split arrow to expand all down one level in the hierarchy. Having done that, you can see that the result of the previous year function is quite dramatically different to that of the same period last year and the DateAdd -1 year. If I drill down to the next level again, so I can see the individual months as well as the quarters and years, again you can see that the behaviour of that the previous year function is quite different. So no matter what interval of time we're looking at for the previous year function, it's always returning the total for the entire previous year. Previous year takes the last date for any particular filter context. So for example, if I pick May 2006, the last date in that filter context is the 31st of May 2006. That date is shifted back to the previous year, so we get the 31st of May 2005, and then the range is expanded to include the entire year. So the range of dates for any interval displayed in 2006 is always the entire year for 2005. If we move into 2007, every single interval displays the grand total for 2006, and so on and so on and so on. You'll see that same behaviour with all of the previous or next interval functions. Just to demonstrate that, let's have a look at comparing quarters. I'm going to first of all head back to the sum runtime previous year 2 function, the one that uses the DateAdd function, and I'm going to copy that one and then create a new measure, paste on all the code that I've just copied, and then change its name to be sum runtime previous quarter, or at least an abbreviation of that. All I'm going to do here is change the interval I'm using in the DateAdd function from year to quarter, and then I can create that new measure. Then I'm going to head back to the sum runtime previous year 3 function that uses the previous year function, copy that measure, and then I'm going to add a new measure, paste in all the code I've just copied, give this an inventive name. I'll call this one sum runtime previous quarter 2, and then this time we'll change the name of the function we're using from previous year to previous quarter. The same parameter is required, so it's the continuous range of dates. So I can create that second measure, then I can add both of these two new measures into my matrix. So let's go with sum runtime previous quarter, sum runtime previous quarter 2, and see what difference it's made. It's probably easier to see if I just drill back up one level so that we're looking at just the year and quarter levels. At this point, most things look pretty similar. So the summary for each individual quarter is the same. So if we're going back one quarter, we get the value for the previous quarter. There's discrepancies in the totals there, of course, which kind of indicate that there is some different behavior going on. But if we were just looking at the quarterly level, then things appear identical. Drilling back down to the monthly level again, though, you'll notice quite a big difference again. So whereas the value for each individual quarter in the DateAdd function is still returning the total for that same period shifted back by one quarter, the previous quarter function is showing the total for the entire previous quarter next to each interval. Now, the point of describing all this isn't just to bore you or put you off watching any more of my videos. The point is just to make you aware that you should be careful about assuming the behaviour of a function, judging only by its name. And I think that in turn leads you to be a little more careful about the way you name your measures as well. If I just tidy up the matrix a little bit, I'm going to get rid of everything except for the original sum of runtime and then the sum runtimes previous years 2 and 3. If I just drill back up again so that we can see just the yearly level, the fact that these two measures have almost identical names, sum runtime previous year, I think that does fairly accurately describe what those measures are showing. But as soon as we start drilling down, the different results displayed here should make you think a little more carefully, I think, about what names to use. I think perhaps a better name for this sum runtime previous year 2 would be perhaps sum runtime same period previous year. So let's just update that. same period or same interval, much like the SamePeriodLastYear function quite accurately describes what it does. We could then rename the sum runtime previous year 3 to say something like sum runtime entire previous year, or maybe total runtime previous year, but something which more accurately indicates what it is returning. So what might be the point of returning the total runtime for the entire previous year next to every quarter and month interval of the current year? Well, one simple reason might be just to calculate the percentage contribution of each interval to the total for the previous year. So to do that, let's just quickly tidy up this matrix again. I want to show just the sum of runtime for the current interval and then the sum of runtime for the entire previous year. If I take this value and divide it by this value, we'll get the percentage contribution to the previous year's total. So to make that work, let's add a new measure. I'm going to call this one sum runtime, percentage of previous year total, and make this one equal to, I think the actual expression is shorter than the name of the measure this time, so we're going to use the divide function, and the numerator will be the sum of runtime measure, and the denominator will be the sum of runtime for the entire previous year. I think this demonstrates the importance of having sensible measure names so you know exactly what you're getting. Okay, so having done that, maybe I'll just quickly tidy this layout up a little bit as well, just to make it easier to read. Okay, and then once we've done that, we can enter this measure. I'm just going to change the formatting as well, so it's formatted as a percentage. And then I'm going to add that one into the matrix, and we ought to be able to see at this point how each quarter of the current year contributed to the grand total for the previous year. Also how the grand total for the year compares to the grand total of the previous year. So in 2006, it looks like we released more minutes of movies. And if we drill down into the months, we can see that same basic statistic broken down by smaller intervals. At the start of the video, we looked at two different ways to go back to the same interval in the previous year. So we saw there was the SamePeriodLastYear function, which always goes back by 1 year. And we also saw that we could use the DateAdd function, specifying this time that we want to go back -1 year, but with the flexibility to add just the number of intervals and the intervals themselves. We've also seen how to go back 1 year and get the entire previous year. So we looked at using the PreviousYear function. Now the PreviousYear function, much like the SamePeriodLastYear function, always goes back 1 year. With previous year, we've also got next year. We've got previous quarter and next quarter, so we do have a bit more flexibility to go forwards and backwards by one interval. But what if we want even more flexibility than that? Is there an equivalent function to the DateAdd function, but to get the entire period? So go back 1 year or any number of years and get the entire year. Well, there is, and the function is called ParallelPeriod. Just to quickly demonstrate this, I'm going to replicate what we've done with the sum of runtime for the entire previous year using the ParallelPeriod function. The measure I'm going to copy though is the one that uses the DateAdd function, because the basic syntax is pretty much the same. So I'm going to copy the sum runtime same period previous year, and then I'm going to create a new measure. And then I'm going to say sum runtime entire previous year 2, because we've already got a measure called that one. I really need better naming conventions for my measures. And then we're going to change the DateAdd function to the ParallelPeriod function. Now, just to show you that the range of parameters for ParallelPeriod, you need to start by referencing the range of continuous dates. So that's movies release date.date. Then it's the number of intervals, and then what specific interval you want to use. So we're going to go back 1 year. Just to quickly mention that there's a slightly different list of intervals you can go with ParallelPeriod. So it's only month, quarter, and year. You can't use days with this function. Anyway, we're going to go back 1 year and we'll get the entire range of dates for that interval. So in this case, we'll get the entire year. So I'm going to create this new measure, And then I'm going to place this one side by side in this matrix with the sum of runtime entire previous year, just to show that we get the exact same results using parallel period as we do with the previous year function. But, of course, with this added flexibility of going forwards and backwards any number of increments of years, quarters or months. One useful thing we could do here with the ParallelPeriod function is get the total runtime for the same year that the interval belongs to. So while calculating the percentage of the previous year total is kind of interesting, I suppose, calculating the percentage of the same year total might actually be more useful. So let's just update this sum runtime entire previous year 2 measure. I'm going to call this one sum runtime entire same year, and then we can get rid of the extra number 2 at the end. So basically I want to shift forwards or backwards 0 intervals, and I want to return the results for the entire year. So if I update that measure now, we'll see that next to every individual interval we get the grand total for the year that that interval belongs to. Then what we could do fairly simply is make a copy of this sum runtime percentage of previous year total measure, and then paste that into a new measure, and then change its name so it's of same year total, and then refer to the sum runtime entire same year. Okay, so having done that, we can create that new measure, format that as a percentage, and then drop that into the matrix. And there we go. So we've seen several techniques for moving forwards and backwards by set intervals, but what if you want to specify an exact range of dates for your measures? For example, maybe you want to count the number of parties that happened at number 10 Downing Street during the COVID lockdown period. Or on a maybe slightly less controversial and perhaps more movie-related note, maybe you want to work out the sum of runtime during the Writers Guild of America strike between the 5th of November 2007 and the 12th of Feb 2008. I'm not expecting anything interesting to turn up in terms of the statistics here, by the way. This is purely to show you how to enter specific dates in a measure. So let's head back to the Power BI desktop app, and then we can add a new measure to the measures table. I'm going to call this one sum runtime during strike. And we'll make this one equal to the calculate function. And we're going to refer to the sum of runtime measure. And then we're going to apply a filter to the date range for each interval using the DatesBetween function. So the DatesBetween function has 3 parameters, the first one being, once again, the continuous range of dates contained in your date table. So that's movies release date.date. And then we need to specify the start date and the end date. Now, if you've worked with other Microsoft products, you'll probably be aware of a range of different ways of typing explicit dates into expressions and programming languages. One thing that you don't do, if I wanted to enter the start date here of 5th of November 2007, is you don't just start typing your date directly in. Now, apologies to anyone watching in the US, I'm in the UK and I've got UK regional settings, so if you bear with me while I enter my date as 5/11, 5th of November 2007, that isn't going to be treated as a date at all. That's going to be treated as an expression, 5 divided by 11 divided by 2007. So one fairly common way to try to enter your date, or try to get your programming language to interpret what you've written as a date, is to try to enter it as a string, as text. So if I wrap some double quotes around that, that will send text to the DatesBetween function, and then it will attempt to interpret that string of text as a date. So it's quite important, of course, that you enter something here that is actually a date. If I try to enter the value Boris, for example, that's clearly not going to work. So I want to make sure that that's something which could legitimately be interpreted as a date. Then you've got the question of ambiguity. So I just mentioned the fact that I'm in the UK. 5/11 is the way that I write my dates for 5th of November. That's not May the 11th. But for somebody else reading this, that might not be obvious. And if I was sending this to different people running this report in different regions of the world, that's potentially ambiguous. So There are various formats you can write your dates in. I could change this to say 5 Nov or 5 November 2011. That's completely unambiguous, and DAX will happily interpret that as a valid date as well. When you're entering text and expecting it to be interpreted as a date, you can often get away with this in DAX. DAX does a reasonably good job of interpreting strings as dates, but there's also actually a dedicated function designed to do exactly this. So the function is called DateValue, and the idea of this is it converts a piece of text into a valid date. So if I say DateValue and then pass in the 5th of November 2007 as a string, that's probably the most reliable, certainly the recommended way to enter dates as strings. Just to enter the end date, I'm going to take a slightly different approach here. I'm going to use a function called date. Now the idea of the date function is that you can specify the different units or the different intervals as numbers. So if I want to specify the 12th of February 2008, I can enter the number 2008, comma, 2 for the month, comma, 12 for the day. I can then close the round brackets for the date function, close the round brackets for the DatesBetween function, and then close the round brackets for the calculate function. So having done all that, if I hit enter to create that measure, I'll then just tidy up this matrix somewhat. Let's get rid of most of the other measures and then just place in the sum of runtime during the strike alongside the original sum of runtime. So the important thing here is that each interval shows the exact same value because each one is looking at the exact same range of dates. If you wanted to check that your measure was using the range of dates you've specified correctly, there are several ways you could check this, but one fairly simple approach would be to add another visual to the report and then apply an explicit filter to it to see if it comes out with the same results. So let's just provide a bit of extra space at the right hand side here, and in that space I'm going to add a basic card visual. Into the card I'm going to add the sum of runtime measure, and initially that will display the grand total sum of runtime completely unfiltered. I'm now just going to expand the filters panel, and I want to be able to filter that card by the release date field. So I need to add the release date field from the fields panel to the add data fields here, filters on this visual section. I'm going to change the filter type from basic to advanced, and then I can choose to show items where the value is on or after. Then I can type in my date, and it gives me a handy hint here, day/month/year. So let's go with 05/11/2007. And then I can say on or before, and then again type in the second date, which would be 12/02/2008. At that point I can hit the apply filter button, and as long as this card now displays the same value as the measure shown in the table or the matrix, I'm happy that that's interpreting the dates correctly. For the final example in this video, I'd like to do something a little more complicated. I want to show the runtime as a 6-month moving average. You've probably seen lots of moving average statistics knocking around these days, particularly when it comes to looking at cases of coronavirus. So here for the UK number of cases, you can see the bar chart or the column chart shows a column for each individual day, but then the blue line shows the 7-day moving average number of cases. So you can hopefully see there that the line smooths out the large fluctuations in daily cases. So to demonstrate how to do that in DAX, let's go back to our report. I'm just going to tidy up the report a bit. Let's close the filters panel and then get rid of that card. And then we can also get rid of the sum of runtime during the strike measure, I think, from that matrix. If we're calculating a monthly moving average, it doesn't really make sense to include summaries for the quarters and years. So let's change the display of that table back to, the matrix back into a table. And then let's get rid of the quarter element as well. So we're just seeing the month and year combinations. So what I want to be able to do is calculate the average runtime for each interval filter context, but I want everything from the last date in that month going backwards 6 months. So for December 2005, the average will incorporate a date range from December 31st, 2005, all the way back to July 1st, 2005. So July, August, September, October, November, December, 6 months. We're going to use a couple of new functions that we haven't encountered yet. And I'm going to show you at least one of those functions as a separate example first. So it's possible to calculate the first date and the last date of a period using some sensibly named functions. Let's just really quickly add a couple of new measures. I'm going to call this one first date of interval. And I'm going to do this one using the first date function. And all we have to specify here is the column containing the continuous range of dates. So as always, for our example, that's movies release date dot date. Okay, so I'll create that measure. Then I'm just going to copy all that code. And then I'm going to create another new measure. And then paste that in. We'll call this one last date of interval. And as you may have already guessed, there is a function called lastDate, requiring exactly the same parameter. So let's add those two into our matrix or our table, and we can hopefully see that all you're getting here for each individual interval displayed in the table, the filter context determines the start date and end date of that interval using those two functions. Next, I want to change the first date of interval measure so that it calculates the first date of the month from 6 months ago. So the 1st of December 2005 will become the 1st of July 2005. So to do that, we can go to the first date of interval measure, and we can nest the DateAdd function inside the first date function to shift this range of dates back by 6 months. So to do that, let's just change the layout of this measure a little bit. Inside first date, we're going to nest the DateAdd function. Then of course, the first thing we need to specify is our continuous range of dates. So that's movies release date dot date. Then I'm going to subtract 5 from that, followed by another comma, and then use the month interval. Okay, so I need to close the extra set of round brackets, of course, for the first date function there, and then we can update this measure and see that our first date is now calculating 6 months backwards. So everything from the start of July through to the end of December, that's our range of dates. Now that we have the date range we need, we can use the DatesBetween function as we did earlier. So let's add a new measure, and I'm going to call this one, what should we call this one? Average runtime or AVG runtime 6 month moving, or some sort of abbreviation of that. And then we can make this one equal to the calculate function. We'll nest the average function in there as we haven't calculated that as a separate measure yet, so average movies runtime. And then to apply the filter, we're going to use the DatesBetween function as we did earlier. So we need to reference our release date field as usual. And then the start date is the measure first date of interval. And the end date is the last date of interval. And if we can close the two sets of round brackets there, and then create that new measure, and then we can add that one into our table to display the 6 month moving average. So that technique worked and we got the end result that we wanted, the 6 month moving average, but it was a little more complicated than it really needed to be. Like with most time intelligence functions in DAX, there are often multiple ways to do the same thing, and there is actually a much easier function we could have used to achieve the same end result here. So I'm just going to start by copying the average runtime 6 month moving measure, and then we can add a new measure, and then paste in all the code we just copied. Let's give it another inventive name, 6 month moving 2, and then I'm going to get rid of the DatesBetween function. And we're just going to pretend for the moment that we hadn't already calculated manually the first date and last date of our interval. We're going to use instead a function called DatesInPeriod. And as usual for the time intelligence functions, inevitably you need to reference the continuous range of dates. So I'm going to refer to movies release date dot date. And then we specify the start date of the range that we're interested in. What I'm going to do is refer to the last date of the period that we're currently in. And again, I'm going to pretend that we haven't already got this in a separate measure. We can just nest the last date function in here and refer to the movies release date dot date. Then, oops, I forgot to close the parentheses there. Bear with me 1 second while I do that. Then we need to specify the number of intervals we want to include. Now, unlike the DateAdd function, the number you enter here is the number of intervals you count forwards or backwards. So previously we used -5 to count 5 months back from the current one. With DatesInPeriod, you're saying how many intervals you want to include. So I want to include the last 6 intervals. So that would include, for example, again, everything from the end of December, the last date in December, to the start of July. So the total is 6 months included. Then I just need to specify what interval I want to use, and of course that's going to be months, and I can close the round brackets there for DatesInPeriod, hit enter, and get the same end result, just in a much simpler, easier way, without having to manually calculate the start date of the interval. Just to demonstrate we get the same result, let's drop that into the table, and you can hopefully see that for each individual month we get the same answer. There's a different result for the grand total, for the overall average. You can see that for the overall average here, you know what range of dates you're using. That's the overall average of every date in that table from the 1st of Jan 2005 to the 31st of December 2016. The average that we're seeing here is the average from the 31st of December 2016, including the last 6 months. So actually the average for the grand total should be the same as the average for the last row. They're the same final values. The total isn't really important there, of course. We're really interested in the 6-month moving average for the individual months. Just to maybe show this in a slightly more interesting visual, let's duplicate page 1 here. And then I'm going to tidy up the table by getting rid of a few of the columns in it. Let's get rid of the first date of interval and last date of interval. And I only really need one of the average runtime 6-month moving. So let's get rid of one of those. Then I'm going to convert this table into a line and column chart. Let's go with a line and clustered column. I want to drill down so that I can see not each individual year, but each individual month and year combination. So let's drill down into that. And then I want to change the second column series to a line. So where it says average runtime 6-month moving in the column values area, let's drag that into the line values area. Then we've got that same sort of style of column chart with moving average line in Power BI form. So there we go. There's a bit about using the date and time intelligence functions to compare different ranges of dates in your measures. Hope you found some of that useful, and hopefully some of it was interesting as well. Thanks very much for watching, and we'll see you next time.